Hello everyone. Today we will talk about the Black-Scholes option pricing model. But before starting the model, I would like to give some information about the option. First of all, let's define the what the options are. So an option is the right but not the obligation to buy or sell an underlying asset at or before a specific date for a specified price. Additionally, if you are dealing with the options, you will see some terms and you need to understand what these are. You will see American options and the European options. So, what are these? An American option is an option that can be exercised at any time until its expiration date. On the other hand, European option is an option that can only be exercised at the expiration date. So you will also see the call option and the put option. Call option is an option that refers to buy, and put option meaning that option to sell. Now let's start about talk about the Black-Scholes option pricing model. So the name of the model comes from the developers. The model is developed by Fisher Black and the Muren Scholes in 1973, and this model comes with the Nobel Prize for the economics. Let's start to explain the model. So equation comes from the some differential calculations. Uh, I wouldn't explain in detail, but I am targeting to give understanding. So let's define the parameters of the model. That's the model. So C0 means that call price at T0. S0 is the stop price at T0, and that's the probability actually cumulative cumulative distribution. So if you are familiar with the statistics, uh, you will understand what it is. So if this is the probability, by the way, it will take value between 0 and 1. So and we have the parameter d1. I will explain later. So k is the strike price, and e to the minus r multiplied by t. Consider that this is kind of discounting the strike price, and again we have some weight for this part of the equation. So what are these actually? What are we doing? We are multiplying stock price, the current stock price, with some probability. Actually, we are weighting this stock price. Again, with multiply the strike price something, we are again weighting this strike price. So consider that first part of the equation is kind of what we are getting, and this part is the actually uh, what we are paying. So by the way, I have a question to you. Uh, we defined what the option is. So according to you, options are valuable under the high volatility or the low volatility. Consider that, because if you understand what the option is, you can understand better to model what we said earlier. Option is the right, but it is not the obligation to buy or to sell underlying assets. Okay, so we are actually buying a right, but it is not the obligation. So therefore, the answer of the options are valuable under high volatility or the low volatility is the high volatility. So if I would like to make some calculations about the option, if I would like to buy option or the sell option, uh, I prefer the stock which has high volatility. So this logic actually reflects to the equation. So in a nominator of the D1, you can see volatility of the stock with square, and denominator we have just a volatility of the stock. So if the volatility of the stock is increased, it means that D1 is increased, because in numerator we have square of the volatility of the stock, and denominator we have just volatility of the stock. So if D1 is increased, and I said that that's the probability which comes from the normal distribution, so this will increase. If the probability is increased, then call price will increase. So let's solve a question, then you will probably understand better how can we apply this formula. But Black-Scholes model actually is a question in general for midterms or the finals. So just understand the question and apply the formula. But please investigate what the formula tries to understand. So you can find the article about the Black-Scholes model. What is the question says that what is the value of call option on a stock if the current price is $70? So it means that S0 is the 70 and the strike price is 80, K is 80. So time to expiration is 9 months, which means 0.75 years, and the standard deviation of stock return is 15%, and risk-free rate is 10%. So now what we need to do is we just need to apply the formula. That's very easy. So let's start to solve the question. So first of all, I would like to calculate the D1 and D2 to calculate the probability. So D1 will be natural logarithm of current stock price and the divided by the strike price. 70 divided by 80 plus risk-free rate, which is 10%, plus square root of the deviation divided by 2 multiplied by 0.75, and we need to divide this. So for the better writing, it is hard to write without pencil. So in denominator we have 0.1 multiplied by square root of 0.75. So at the end of the day, D1 will be minus 0.386, and D2, if I apply this formula, will be minus 0.51. So let's give one more digit, 515. So then we should calculate these two probability. So if I would like to calculate, so it will be 1 minus 0.386 probability of 0.386. So now I need to look at the Z table. So minus 0.36, what it is, 0.64. 0.64, and it will be mm, 0.35, and n minus 0. Will be equal to 1 minus 0.515, and it will be 0.30. So we calculate what we need. So now we just need to apply the formula. It is very easy. So if we apply the formula, we will find that 70 multiplied by 0.35 and minus 80 e to 0.10 multiplied by 0.75 and multiplied by 0.30, and it will give us a $2. So that's easy. So it means that a call option on a single share of stock should be priced at $2 under these parameters. So we said that options are valuable under the high volatility, and actually formula use this logic. For put option, there will be a minor different calculation. In further video we will investigate that also. That's it. Please subscribe to channel. See you, take care of yourself.